Question 8 is coming from differentiation. The diagram shows the curve with this equation for x greater than 0 and its minimum point m. That means this is the stationary point. So find the exact values of m. We know that for stationary points, dy dx is equal to 0. Now we are going to differentiate this, but we are going to use the product rule because this is a product of two functions. Okay, so I will keep this one constant, then differentiate natural log of x, and then I will add natural log of x here, then I differentiate this x cubed. Okay, then from there I will equate this one to 0. Okay, so when you differentiate a natural log, you just get here, you differentiate that. Remember, when you differentiate a natural log of a function, you get that function, you differentiate it, then you divide by that same function here. So that is what we are going to use there. Okay, this one will be x cubed, then times, when you differentiate here, you get 1. Then 1 divided by that x, then plus, this will be natural log of x, then times, here we shall get 3x squared. 3x squared, which is equal to 0. And this one, of course, will be x squared, then plus. It is better you write this one first, such that it doesn't interfere with this one. So I'll write 3x squared, then natural log of x, which is equal to 0. Now x squared is common. I can factorize it out. Then we have 1 plus 3, then natural log of x, which is equal to 0. So meaning you can get this one here, you equate it to 0, and then x becomes 0. So you can actually see here that the turning point here, there is also another turning point here. It is probably maximum there. And then 1 plus 3 natural log of x then will be equal to 0. So take 1 the other side. We are making x the subject to the formula. It will be a negative 1, then natural log of x will therefore be equal to negative a third, and therefore x is going to be e to the power of negative a third. Now, after getting x as this one here, then what is the value of, what is going to be the value of y? Okay, substitute in this equation here. So our y is going to be equal to x cubed. So we have e power negative a third, then we cube it, then natural log of the x here is e to the power of negative. No, actually, I don't need to waste time there. Already natural log of x is this one here. So I would just say times negative a third. Now, of course, this one will give us e to the power of negative 1, then times this negative a third. So meaning the coordinates of m, I can smartly write them here like this. X is e to the power of negative a third, and then y is going to be negative e power negative 1 over 3. Or you can write 1 over e power a third. Then this one is negative 1 over 3. Then e is down here, the way you want to write it. But I will just stop it there. So this will be our m, or the coordinates of m there. But B, find the exact area of the shaded region bounded by the curve, the x-axis, and the line. X is equal to a half. So the exact area of the region bounded by the curve, x-axis. So if we check again here, x-axis and then a half. This is the one actually here. Okay. X is equal to a half. This is the line. Then this is the x-axis and then the curve. So we need to know this coordinate here. Okay. Where that graph cuts x-axis. So we shall say that on x-axis, what do you know? Y is equal to 0. So that means our y, which is x power 3, and then natural log of x is equal to 0. You can split this one here. X cubed is equal to 0, and then the natural log of x is equal to 0. So that simply implies that x here is going to be equal to e power 0, which is a 1. Okay? So meaning where this one is cutting x-axis, it is a 1. And then, of course, the 0 is here. So we shall now say that area, actually the shaded area, is going to be equal to the integral from a half then to 1. Okay? And then this is x cubed, then the natural log of x, then dx. But then you realize that this area here is below the x-axis. That means when we integrate, we are going to get a negative answer, and area cannot be a negative. So I'll put the modular signs here to make this one positive. Okay? Now, we are going to use integration by parts here because this is a product of two functions. And for integration by parts, I've always shared that you use this acronym, ILATE. This is for inverse trigonometric functions. This is for logarithmic functions. This is for algebraic functions. This is for trigonometric functions. This is for exponential functions. But now we are seeing algebraic. So that is what we are going to take. We are taking this one and then logarithmic functions. That is here. So the one that comes before the other is the one we differentiate. So logarithmic comes before the algebraic. So meaning we are going to have u. We are going to have our u. So let u be equal to that which you are going to differentiate, the logarithmic function. So you differentiate it, du dx. I say the one that comes before is the one you differentiate. So this one is going to be 1 over x. And then dv dx, the one we are going to integrate, is equal to the algebraic. That is x power 4. Now v is going to be the integral of this one here. You increase, this one is actually x power 3. So you increase the power by 1, and then you divide by the new power. So this will be x power 4 over 4. I don't need to put plus c, okay? I don't need that here. Now, we are going to have, since integration by parts is you are integrating u, then dv dx with respect to x, which is equal to uv minus the integral of v, then du dx with respect to x. That means that our shaded area is going to be equal to the modulus. Now, what is our u? Is natural log of x, then times our v is this one here. So I will write this one first so that I don't interfere with this x here. So x power 4 out of 4 here minus now the integral. V is x power 4 over 4, then times du dx is this one here, which is 1 over x, and then with respect to x here. Okay, so here I'm actually going to put the limits. We have 1 and then a half here, but then in the modulus signs. Now we can continue. In here, this one is going to be x power 4 over 4, then the natural log of x minus, this one is going to reduce this to x cubed. Okay, we have our limits here, 1.5, but already this one we have seen, it is this one here. Now here there is also a quarter here, there is a 4 here, so I'll put that a quarter outside here, so minus then a quarter here. So meaning we shall have x power 4 over 4, then natural log of x, then minus a quarter, then times. This one is x power 4 over 4. Remember, it is the same as this one here. And then we put these limits in the modular signs. Now, putting the limits, we shall have 1 over 4, natural log of 1, of course that will be 0, then minus this will be 1 over 16, then times 1, okay, times this one here. When you put 1 power 4, that will be 1. Then from there, we subtract. When we put a quarter, this is, a half, power 1 over 4, this will be 1 over 16, okay? Then there is a 4 here, so divide by 4, that will be times 1 over 4, so that will be 1 over 64, okay? So I'll have here 1 over 64, then the natural log of 1 over 2, then minus, remember this is 1 over 16, and then you have this one here, which is 1 over 16 also, 1 over 16. These are half, power 4. Then we put the modular signs. Of course, this one is 0, like I said before. This is negative 1 over 16. And then here, we open the brackets, that will be minus 1 over 64. But a half is the same as 2 power negative 1, okay? And then a negative and a negative, that's a plus. 16 times 16, that is 256. So we shall have plus 25. No. It is 1 over 256 modulus. Now this minus can come here and makes it a plus, okay? So we shall have these two here, 1 over 256, then minus 1 over 16. 1 over 256 minus 1 out of 256 minus 1 out of 16. That is negative 15. So negative 15 out of 256. Then plus, because this one has come here and then it has multiplied with that, plus 1 over 64, then the natural log of 2. Okay, like that. The modulus of this one here, I can leave my answer there, but again, this is the same way as saying this whole thing is going to give us a negative, okay? So if it gives us a negative, let's actually just check it out. Minus 15 out of 256, then plus 1 over 64, then times the natural log of 2. The whole answer is a negative, right? So the modulus makes it a positive. So I can say the negative of whatever is coming from here to make our answer a positive, okay? And then our answer becomes, what was negative now becomes a positive, so that is 15 out of 256. Then what was positive now becomes a negative, so minus 1 out of 64, then the natural log of 2. And that is that.